Okay, guys, so I created an assessment in School City, an exit ticket assessment, because we have to start doing our process and our due diligence with completing exit tickets and snapshot assessments and so on and so forth, and unit assessments. So I went through and I'm using this as an example, kind of like a guinea pig example process for us to go through and see how it works out. And then we'll actually roll out our actual snapshot for this first units that we've completed in School City. So give me a second. I'm going to go ahead and go through this process as a review. I am going to take it as a completion grade, but also as a review. So there's absolutely no excuse unless you're just not paying attention to instruction and going through and watching the videos as you should be doing every time you come to Algebra 2 class. So let's do this first question. This first question is going over solving absolute value equations. That's the first concept, unit concept that we're actually supposed to go through and be able to understand with fidelity as best as possible for the Algebra 2 curriculum. So this question says, what positive value of x makes the equation absolute value of 8 minus 2x equals 16 true? So we're going to go through and work this process the way you were taught to work it by myself when we were downstairs in the library. All right? So the first thing that we're going to do is first we have to recall and remember, what does taking the absolute value of something actually mean? Because if you don't ask yourself that question first, then you're going to be confused going through the entire process of actually having to solve this. So question number one is, what does absolute value actually mean? Let me go here. So you have to ask yourself, what does absolute value actually mean? That's going to be the first question that you need to assess yourself before you can even go through and tackle how you need to go about solving this. So when we're taking the absolute value, when we see these two bars or these two lines inside our problem, we need to make sure we know what the problem is actually asking us. This problem is actually asking us what value of x is going to make this a true statement for giving me a distance. That's what absolute value actually means, that's equal to 16. So we want our distance equal to 16. So when we set up our problem, if we can think back to when we were downstairs, we know that there's two distances on a number line that gives me a distance of 16. You have positive 16 and you have negative 16. That's both a distance of 16 units away from 0. So when I set up this problem, let me go and make my pen a little larger. I'm going to write, so now I want to get rid of this absolute value. That way I can solve it the way I'm used to solving it back with the algebraic concepts. So I'm going to set this up as 8 minus 2x equals positive 16. That gives me a distance of 16. That way I can easily and simply solve for x, doing all those review processes that we reviewed at the beginning of the year. Then I'm going to set up another case. So case 2 is going to be 8 minus 2x equals what? Negative 16. Both of these equations give me a distance of 16. So we've technically already taken the absolute value of this problem by breaking it up into two situations. So hopefully you understand that. When you break it up into the two different situations, that is you taking the absolute value that equals a distance of 16. So now we're going to go through and work both of these situations. All right? So over here on the left side or the right side, I'm going to solve for x. Remember, ask yourself the question, what's happening to x? And that's going to give you the process that you need to go to inverse everything to get x by itself. All right, so the first thing I'm going to do is this is a positive 8, so I'm going to subtract 8 from both sides. All right, 8 minus 8 is a zero pair. It cancels. And it leaves me with negative 2x equals 16 minus 8 is positive 8. All right? Now, easy peasy, Alice squeezy. We are down to a 6th grade level problem. I'm solving for x now. Something that we learned back in 6th grade. So now, if I want to get x by itself, I ask myself the question, what's happening to x right now? Well, right now, it's being multiplied by negative 2. So we're going to have to do the inverse of multiply by negative 2, which is to what? Divide by negative 2 on both sides of the equal sign. Negative 2 divided by negative 2 crosses out. So I'm left with x on this side equals 8 divided by negative 2 gives me negative 4. That's one of my potential solutions. Now, remember, we're taking absolute value, so we have to do the same thing and solve for x on the other side, where we had a different problem. So I'm going to go through and do the same thing here. I'm putting my box around the x. Why do I do that? Because I know if it's not in this box with x, it has to be moved to the other side. How do I move it to the other side? By doing the opposite or the inverse of what's happening to x right now. So I'm going to start with the 8. Right? It's kind of like working your way into the x. Right now, the 8 is the furthest away from x, so I'm going to subtract 8 from both sides of the equal sign. All right, I'm left with 8 minus 8. That's a zero pair. It cancels out. So now I'm left with negative 2x equals negative 16, take away 8. All right? That's negative 24. So we have negative 2x equals negative 24. Now I'm going to divide, well, what's happening? I asked myself that question again. What's happening to x right now? Well, right now that we've gotten rid of the 8, right now all I'm doing is multiplying x by negative 2. So what's the inverse of multiply by negative 2? I'm going to go and divide both sides by negative 2. Our negative 2 divided by negative 2 cancels out because it's equal to 1. So now I'm left with 1x, or just x, equals negative 24 divided by negative 2. Your negatives cancel and become positives. 24 divided by 2 is 12. That's another potential solution for this absolute value equation. And now the question says, what positive value of x makes this absolute value equation true? Our answer should be 12. 12 was the positive answer that we got for this solution set. All right, so let me know if you have any questions or working problems like this. We have another one that's going to come up, but I wanted to make sure you're exposed and remember how we solve for x. All right, remember also you have to check your solutions. So we would go through, had the question not been worded this way, we know the positive answer is going to be our answer, but we would have to go through and check these answers into the original absolute value equation. All right, let's go to another one. All right, so now I'm going to go to number 2. All right, so number 2 says, what is the solution set? Solution set basically just means what are the solutions for this absolute value equation? We're pretty much going to do the same thing, all right, that we just did on the previous problem. All right, this is a little bit bigger problem, but I'm still going to work it the same way. So the first thing I'm going to do is this problem has 3 times the absolute value of 5 minus x, close absolute value plus 2 equals 29. The first thing I'm going to do is try to isolate my absolute value. So I'm trying to isolate this. Isolate means to get this part that's only the absolute value by itself. So what would I do first? I'm going to subtract 2 from both sides. Okay, positive 2 minus 2, that's a zero pair. It cancels, and it leaves me with 3 times the absolute value of 5 minus x equals 29. Take away 2 is 27. All right, from there, I'm going to get rid of this 3. So we're basically treating the absolute value like it's a big x value. So now I'm going to get rid of this multiply by 3. What's the inverse of multiply by 3? I'm going to go and divide both sides, the entire side, by 3. 3 divided by 3 cancels out. And it leaves me now with the absolute value of 5 minus x equals 27 divided by 3 is 9. So now, what am I solving for? I'm trying to figure out what is the value of x that I can plug inside this absolute value that'll give me the distance of 9. That's what absolute value means. How far is the number away from 9? All right, or away from 0. We wanted 9 distances or 9 units away from 0. So whatever it's equal to, that's giving you what they want that distance to equal to. And we need to make sure the x values fit it accordingly. All right, so we're going to do the same thing we just did on the previous problem. We're going to set up 2 situations, but what am I going to set up 2 situations for? I'm going to set up 2 situations not for this equation, but for this simplified equation to where it's isolated to a single expression inside the absolute value bars. All right, if you have other stuff, you need to move that other stuff to the other side. All right, so I'm going to switch colors real quick so I can move on. I'm going to switch to blue. This now becomes my problem. The absolute value of 5 minus x equals 9. So I'm going to set up 2 cases. All right, I want to get rid of these absolute value bars, so that's why we set up 2 situations or two cases. So my first case is going to be 5 minus x equals positive 9. And remember, if we want to get rid of the absolute value bars, we're going to have to also compare it to 5 minus x equals negative 9. A positive and a negative, we have 2 distances that's 9 units away from 0. All right, so I'm going to go through and work both of these. And this one should be a little bit easier. We're solving for x. I put my box around the x. First things first, I move this positive 5 out here. How do I move positive 5? The inverse of positive 5 is negative 5 or minus 5. 5 minus 5 is a 0 pair. It cancels. And now I have to be precise about what I write. I'm left with minus x equals 9 minus 5, which is 4. Okay, and a lot of people tend to think, well, we have x by itself now, so our answer is positive 4. No, it's not, because we still have this minus sign in front of the x. That minus sign is attached to that x value. It's in front of it. So I need to move the minus sign to the other side also. All right? So now, what's the inverse of multiplying what's happening to x right now? I asked myself that question. Well, right now, this looks like x times a minus, or x times a negative, or x times negative 1. So what's the inverse of multiply by negative 1? I'm going to go and divide both sides by negative 1, or by a negative. It doesn't matter. Well, over here, what actually happens, it cancels out. So on negative over a negative becomes a positive. So I'm left with positive x equals 4 divided by negative 1 is negative 4. That's one of my solutions. Okay? Now let's go and do this last one. Same thing that I just did, I'm solving for x. Okay? So what do I need to move? Who do I need to move? Well, I see what's not in that box with x is the 5 and this minus sign. That's going to eventually turn into a negative sign. All right, so I'm going to move the 5 first. This is a positive 5, so I'm going to subtract 5 from both sides. 5 minus 5 is 0. It cancels out. So now I'm left with minus x or negative x equals, I probably shouldn't write that right there, minus x equals negative 9 minus 5 gives you minus 14. Okay? Now I ask myself the question, what's happening to x now? Well, right now this looks clearly like negative x equals negative 14. So how do I get rid of that negative? Well, the negative is being multiplied by x, so I'm going to divide by a negative on both sides. This is the other way that you could have done this first side over here. All right? Well, a negative over a negative becomes a positive, so it turns into positive x equals a negative 14 over a negative or a negative 1 is positive 14. So I get solutions that are -4 and +14. Does that look like we're on the right path by looking at these answer choices? Yes, it does. All right. I see a -4 and a +14. I see a -14 and a +4. We didn't quite get those. So I'm going to cancel this one out because we didn't get answer choice C. We got a +14 and a -4. And then now we got to decide, is the answer going to be -4 by itself? Is it +4 by itself? Or is it both of them combined together? All right. And actually it wouldn't be B because we got -4 by itself, not +4. So the answer is either -4 or it's both of them. All right. So this is where you have to go and check your answers to make sure which one doesn't actually work. How do you check your answers? By going back to your original problem and plugging in what the answers that you got back into the original problem. Not the revised problem, but the original problem. All right? So we're going to go back through this, and I'm going to try to open a blank sheet of paper. I'm going to do this. All right, we got x equals -14 and x equals +4 or -4. +14 and -4. All right, so here we go. X equals +14, x equals -4. That's what we got, but we need to check to see which one of these actually works or if both of them actually work. So I'm going back to this original problem, right, to see. So we know our answer choices that we narrowed it down to was either A or either D, based on process of elimination. So now we have a 50% chance of getting this problem right. So I'm going to check 14 first. So how do I check 14? I'm plugging X in. I'm going to substitute 14 in for X. So here we go. 3 times the absolute value of 5 minus, I'm going to switch colors real quick, 14 close absolute value plus 2 equals 29. Okay, now let's go through and clean all of this up and see if we get a true statement in the end. All right, so first things first, I'm going to move this +2 to the other side. All right, so when I move the +2 to the other side, I'm going to subtract 2, 0 pair, it cancels. 3 times the absolute value of 5 minus 14 should equal 29 minus 2 is 27. Okay, now what I'm going to do is I'm going to go and divide by 3 on both sides. So I get the absolute value. I'm going to come over here. The absolute value of 5 minus 14 should equal 9. All right, now I think to myself, what is 5 take away 14? I get -9. So I'm left with the absolute value of -9 should equal 9. I want to know, is this a true statement? Is the absolute value of -9 equal to 9? So I ask myself, how far is -9 away from 0? I'm asking myself the absolute value question. Well, the distance -9 is away from 0 is 9. So the absolute value of -9 is 9. Since 9 equals 9, that is a true statement. So what does that tell me? That tells me that 14 actually does work. So I know the answer now. I don't even have to go any further. Is not A. Because A does not include 14 as the answer. The only possible answer would be D. And I don't even have to check -4. -4 should work as well. All right? But just for your sake and so you'll understand and know, I'm going to go through and show you guys that -4 is going to actually work. All right? So we got X equals -4. I'm going to plug -4 in right here for X. All right, so 3 times the absolute value of 5 minus negative 4. Shouldn't have done that like that. Minus negative 4. Close absolute value plus 2 should equal 29. Let's go through and see if this works with me substituting the answer that we got, negative 4, back in this problem, original problem. All right, so I know when I have a minus and negative, this changes to a big plus sign. So I'm gonna have 3 times the absolute value of 5 plus 4, close absolute value plus 2 should equal 29. All right, I go through and I solve. So first thing I'm gonna do is subtract 2. This is a 0 pair. I'm left with 3 times the absolute value of 5 plus 4. 29 minus 2 is 27. All right, now I'm gonna go and divide by 3 on both sides. 3's cancel. So I get the absolute value of 5 plus 4 should equal 27 divided by 3. That gives me 9. Now I can work this out and get a single number inside the absolute value so I can actually take absolute value. 5 plus 4. What is 5 plus 4? It's 9. Now I ask myself, what is the absolute value of 9? The distance that 9 is from 0 is 9. Since 9 does equals 9, it does give me a true statement, which proves that negative 4 is a solution also. So that goes through that process. All right, let's go to the next problem. All right, so it says graph the function shown. Let me see if I can actually see the function.
Hey, gonna get chipped too. Another one bites the dust. Hey man, what is going on here, man? Oh, from yesterday? Oh, okay. All right. But say, hold on, man.
He's doing an announcement.